everyone, it's Mrs. Mosier. Just going to create a video showing everyone how we use the area model to solve for long division. I will also compare it to the standard algorithm, also known as the old school way, that all of us have learned when we were younger, a lot of the families. I teach the area model because of the curriculum. Also, though, the last few years it is on the state test as well. Students can still use the standard algorithm if that is what you guys are practicing at home. I've always said any way they can solve is perfectly fine, just so long as students are listening in class to the area model and understanding that they will use it in 5th grade and they will see it on the state test, which of course are big reasons why we are learning it. Sorry if my video tries to, or the camera, it keeps trying to zoom in and out constantly. But just wanting everybody to be aware that any way they solve is completely fine, but I do want to make sure they are listening and making sure they're paying attention to the area model, because it is something that they will be still using in 5th grade. And I mean, I do think in a lot of ways the standard way that we all have practiced before in the past is quicker if you make sure you memorize those steps. The problem is, I do get what they're saying with Common Core, is that you don't understand then what's happening or how with place value, and I think that's really why Common Core created these different ways of mental math. So I think there's definitely benefits to both sides. So just wanted to say that before starting, is of course just knowing that I definitely understand there are quicker ways to go about this for sure. I think that the area model is just trying to break down mental math ways that students can do their long division and also apply more of the practices we do in class compared to that way. That's what I've noticed with it. I do think in some ways they can make it a little bit more of their own and do their own process with the area model than with the actual long division way that we've come to know, that is a lot of just rote memorization. So here's my first example. So if I have 342 divided by 3, I'm going to show the area model first and then the standard algorithm so you guys can see how it compares. First, I have the students take the divisor, put it on the outside of a rectangle, however large or small they would like to create it. What we practice in class is that when we look at the dividend or the total, make sure to put it down on the inside first, because really what's happening is you're counting by 3s to try to get as close to this as you can. Of course, division is also splitting this into 3 groups, but what you have is students trying to make tallies or make 3 groups, and they're trying to count to 342, and we want to make sure that they're using their skills more efficiently, and that's why, of course, there's the long division standard algorithm and then this area model. So first, what I have students do is I usually will say, okay, with your total here, or whatever you're working with, cover up the 2 digits or however many are behind it and just start with the first one, just like you would do with long division that we commonly know. How many 3s, if you skip count by 3s, how many 3s get you to 3? And students are like, oh, well, 3 times 1 is 3, so it's itself. So we usually put a 1 up here, and then I say, okay, how many numbers were covered while you were doing that? 2. We're going to put 2 zeros in its place because this number is in the hundreds, and we really want to try to get as close as we can without having to do too much work. Students can do the area models however they want. They don't have to start like this. I just like to show them by place value how can we get as close to where we want to be as we can without having to drag this on too long. So 3 times 100 is what we will do first, which is 300. And just like with regular long division, you need to subtract. So 342 minus 300 is 42. The students draw a line because they've done the first place value box here, put a plus, and they repeat, just like with the standard long division. Same thing. Some students are able to do this mentally. Others, they still need to kind of cover that up. How many 3s get close to 4? Because, of course, if you count by 3s, you don't hit 4. But one group of 3 is as close as we're going to get. And then I had 1 digit covered, so I'm going to put 1 0 in its place. Or, of course, you could say because this is in the tens, and we want to get it into the tens place here. So 3 times 10 is 30. And again, we subtract. 42 minus 30 is 12. You block that off, and we repeat. Now here, students should know that 3 times 4 is exactly 12. So 3 times 4 is 12, subtract, you get 0, and you are done. This is also what we call the partial quotients, because the quotient is the answer to a division problem. So the reason these are partial is because they're part of the whole. So when you put them together, you get the quotient of 114, which is the answer here. And I want to show you how this connects to the standard algorithm way that we, meaning adults, most likely learned in school. 342, so same thing. How many 3's go into 3? 1. 3 times 1 is 3. Subtract 0. Okay, and then bring it down. I didn't say that part. We always bring it down. Then we repeat. So you can see first we had that 1 in the hundreds place like over here. I brought down my 4. I repeated, and same thing like over here. We said how many 3's get to 4, and we put a 1. The only difference was that, again, we used the entire place value here. Here we're just, again, doing it like one digit at a time. So 3 times 1 is 3, subtract, bring it down, repeat. How many 3's go into 4? 1 is as close as we can get because 3 times 2 is 6. So 3 times 1 is, again, 3. Subtract, bring it down, repeat. And you can see how, again, we get 12. How many 3's go into 12? 4. 3 times 4 is 12, and you end up with the same quotient. So again, I really think it just depends on how much practice and understanding goes into this, because I do feel like they take the same amount of time, but of course this is going to be more challenging based on the place value. A lot of students do struggle with the zeros, especially when we have to work to the thousands, because the Ohio standards say that students will be able to divide 4 digits by 1 digit by the end of the year. So that does get harder. So I definitely think, steps-wise, I feel like steps-wise this is more challenging, but of course the numbers are smaller, so you're not having to do quite as much processing of the place values. So in that way, this way is challenging if you're thinking of like, okay, you're having to figure out, it's a little bit more open-ended of what to multiply by and how far to go. But the more that the students practice this, they do figure out how to do it in less steps related to this. I do feel like if I show you a quick, like some students use it their own way and they don't do the first way I showed you here where like they're trying to get as big as they can. They might start smaller, but in the end it's okay because it's them guessing and checking and using their skills to get them where they need to go, and they'll still end up with the same answer. So a lot of students might have said like, oh, I don't know, 3 times 50, because I know 3 times 50 is 150. And so this is just me going through like how, what I do like about this way is that you have students who might struggle with more of the place value of their facts, so they can really do this in any way they want and they'll still get the same answer. Again, I am teaching them in class. Let's try to go based on place value and let's get it done quickly. But some students, just when they go on their own, they will solve differently and they still get the same answer. It might just take them longer. But I feel like that is nice because I do tell them, with this way right here, you cannot make a mistake. You cannot change the numbers. Even if you see something place value wise that you want to do, you really can't do that. You have to stick to the steps. But this, if you wanted to do something different, like if a student here, if they're like, oh, okay, did I borrow that correctly? Yes. I'm going to do 3 times 50 again. 3 times 50 is 150. So look, we have 42 again. Repeat 42. Okay, now I'm going to do 10. And then they just, again, could draw another box. So I just wanted you guys to see that this is the thing I do like about it, is that it can be manipulated to however students want to solve, and they will still get the same answer if they follow the steps. And that is nice depending on those who are still practicing and solving at their level. And it might be different. Like this might be a student who's a little bit of a higher math student is able to grasp this, and this might be a student who's still working with those larger to practice and learn those larger place values and might just need to break it down and take a little bit more of their own time to get where they need to go. And eventually they'll figure that out. Okay, the last one here, if we did to the thousands just quickly, so if we had 2,684 divided by 5, I'm trying not to make this video too long, but I knew that it would be, put that dividend, yes, the dividend. So we have our divisor, we are using these words in class, our divisor and our dividend or the total in here, and then same thing. So if I count by 5s, do I hit 2? Can I get close to 2? No. 5 is already too big. Okay. What if I count by 5s? Can I hit 26? No, but you can get close. How many 5s get you close to 26? 5. And then I move my hand. I had covered 1, 2 digits. So I am going to make this 500 and try to get as close as I can. 5 times 500 or 5 times 5 is 25 with 2 zeros, or 2,500. Oops, I'm not adding that, subtracting. Subtract that. You have 184. Put the plus and repeat. Same thing. If I count by 5s, do I hit 1? Nope. If I count by 5s, do I hit 18? You can get close. You will not hit it perfectly, but 5 times something will get us pretty close to 18. So students will skip count by 5s. And they'll say like 5, 10, 15, 20. 20 is too big. Let's stick with 3. 5 times 3 is 15. I had 1 digit covered. We're going to make it 30. 5 times 30. 5 times 3 is 15. And again, with my 0 here. So we've been doing this all year, practicing with our zeros, talking about what it means and how to place those. I always tell students I love zeros because if you figure out how to work with them, you save yourself so much time and you don't have to do quite as much solving as long as you know how to use them and where they go with our place value chart that we've been practicing with. 4 minus 0 is 4, 8 minus 5 is 3. Repeat. Okay, and at this point, kids will know how many 5s go to 34. 5 times 7 is too big. We're going to do 5 times 6, which is 30. And then you subtract and get 4. And some students might make another box, or they just might say, oh, 4 is the remainder. So then here's our partial quotients. Our answer is 536, remainder 4. Okay, and again, if I compare this to the standard algorithm here, it is the same thing. 5, you cannot fit 5 into 2. How many 5s go into 26? 5 is as close as we can get because 5 times 5 is 25. And we subtract that. You get 1. You bring it down and you repeat. And here again, same thing. We had 18 up here and we had 18 here. Remember how many 5s go close to 18 and the students chose 3 as our practice. So same thing. 5 times 3 is 15. 5 times 3 is 15. Subtract. Bring it down. Repeat. 5 goes into 34 again 6 times because 7 is too big. 5 times 6, and again, see how we did that right here? 5 times 6, so it's again the exact same. Minus 30, we have 4, nothing else to bring down. We cannot repeat because 4 is too small. And 536 remainder form, we got the same, and it was the same amount of steps. Again, if they just go right to their place value of, you know, trying to get to the thousands here, trying to get to the hundreds, trying to get down to the tens and the ones. So this is what we've been practicing. I just wanted to have a moment to show families. I will be posting this to Google Classroom as well so students can go back and reflect and use this as notes if needed. But please let me know if you have any further questions. Again, this does take time and practice. It took me a while to practice it myself and learn some little strategies to help make it easier for the students. Long division and place value are the most challenging 4th grade standards that we have math-wise. Fractions is more simple. Decimals and fractions connect. Geometry isn't as challenging. We've done addition. We've done subtraction. I do still have students struggling with subtraction every year. That is another one. But, you know, rounding, patterns, really nothing is quite as challenging as place value and long division. You can see how much their multiplication facts does factor into this as well. So Side note, students can be going to their Clever account and going on Extra Math. It is on my Clever page, and that is a good way for them to be quickly practicing their facts to get more of that in. Let me know if you have any other questions. Thanks so much for your time.